Nice to see you today. And today we continue our work on differential calculus. So I want to dwell your attention on the so-called compound or composite functions. This is the most confound thing and confuse people and students the most. These composite functions calculation, derivative calculation. So I have here some markers and I put down our topic. Context. Composite or compound functions. Firstly, we have to understand the concept of the compound functions. Look, firstly, I give you some examples. I use the black ink here. The first one thing. For example, x. You have a given function y equal x. So we can write down that f of x is just x is itself. So I remind you the reading of this phrase. Mapping f of x sends a number x to number y, which is calculated like f of x. Or we can write down this thing like f of x colon x is sent to a number y. Okay. You can notice that we have to, if you want to calculate to know the value of y, you have to make only one operations. For example, if x equal 1, y equal, according to this function or mapping, just this one. So it means that this function f of x equal x sends x number to the same number. For example, you have this function x squared, and here we have noticed that mapping f of x equal x squared. By the way, it's still y. Mapping x squared, mapping x squared sends a number x to number x squared. So for example, f of x sends 1 to 1 squared, or it is still 1. F of x, f of 1. F of 2 sends 2 into 2 squared, and it is 4. Situation dramatically changes if I add something to this function 3. For example, I want to calculate (1 over x plus 1). At the first glance, we have here a very simple situation. We have just put number x here and calculated the number y. But really, we have absolutely dramatically distinguishedly other situation. We have two steps here. The first one, to calculate y. You have to add to x 1. So the first one function I denote like g of x equal x plus 1, you can say that mapping g of x sends x to x plus 1, or the other denotion g of x sends x to x plus 1. So for example, if x equal 2, g of x sends 2 to 2 plus 1 over to 3. And the second operation here is division. We have to divide one over these new values. So I denote like it, like, if you don't mind, a capital X of g. It's which is 1 over g. So I add to the x1 and divide by this x plus 1 thing. So we can say that mapping f of g sends, drops here, sends g to 1 over g. Oh, another word I can put here on that f of g colon g into 1 over g. But at the same simultaneously, I can make this notation. I don't have enough room here, and I use here this space. I can use still x. It sends x plus 1 into 1 over x plus 1. So, what did I do here? What have I done here? What have I done? I expanded the this compound function into two operations. Firstly, I have to make this addition, and the second one, I have to divide by this numerator, x plus 1, that by this expression. You can notice here that we have the special order of operations, and we can consider this given function of x like a compound function. So I put here the bottom line of this explanation that y can be written down like f of g of x, and here f, it is division by g of x, or 1 over 1 plus x. Okay, so this is this third one example, and now we'll make one new example to understand what is it composite function, a compound function. So let's continue our explanation, and we continue considering one new example. So we are concerned ourselves about this one example, the fourth example, y equals sine of x. How do you think? Is it a composite function or just an elementary function? How do you think? So we can notice here a trigonometry function, and it makes us think that maybe it's a composite function because we can't calculate it elementary. We have to use some calculators, but This is a very elementary function, because we have just one operation, mapping sine x sends a number x to number y, which is equal sine of x. Or we can write down it like, by the way, I can denote like f of x here. So f of x, the given function or given mapping, sends x to the sine x. So we have just one operation to calculate it. But what happens if I add here the power to the x? The situation dramatically changed. We have here two operations. The first one, I denote like g of x. It is x squared. So firstly we have to write up the given x argument of the sign. So I can say that g of x sends x to the x squared. And I denote like g number. Okay? It's other number than in physics. So just g. And the next one operation, we have to calculate sine of x squared. I denote it like f of x or f of g, which sends g into the sine of g. Or we can write down like f of x, which sends x squared into the sine of x squared. These two ways to do the same thing. The same things. So we have, what is the main idea here? We have to make two operations to calculate these functions. So this is an elementary function I put here, the main conclusion. An elementary function. Because we have just one operation here, and here we have two operations. That means that it is a compound function, a composite, a compound, a composite function. I use specially two synonyms here, compound function or composite function, because in some subject books people use compound, in some texts you can find composite functions, so I use both of these terms to explain. And what about, for example, the sixth one example? Y equal 1 plus sine x squared, for example. Here we have squared, sine squared, for example. Firstly, the first operation, sine x, I use here sine x sends x to the sine x. The next operation, sine squared, sends this sine of x into sine squared of x. And next one operation, 1 plus sine squared x sends this new, I denote like w if you don't mind, w into w plus 1. And the last operation is division. So finally y equal 1 over w plus 1. And we have 1, 2, 3, and 4 operations to calculate this function y, this value y. We have to, first one, calculate sine of x, then rise to square sine of x, then add 1, and the last one operation, we have to divide unit by this long expression. Even here you have 4 operations. Now we are ready to make the concept, to define the concept of the compound function. I think that you are ready. And you understand what is it, compound or composite functions. I can say that compound functions, it's a function which can be expanded into set of or chain of operations. Chain of operations. Very important thing here, the word chain of operations. Now, this is a very short explanation, and now you are ready to make your home assignment of this, which is associated with this short theory, piece of theory. So I put down your home assignment. You can write down and make your homework. And do your homework, not make, do your homework. Okay. So we can define f of x as a composite function. Composite function. Function. When it sends x to y number, so that we can identify chains of operations. For example, g of x sends x to the g of x, and then f of g of x sends this g of x to the y. So we have made at least 2 operations. At least 2 operations. These 2 operations. At least 2 operations. As we noticed before, we can have here a set of operations, a chain of operations. And usually we denote this a composite function like y equal f of g of x. That means that firstly we have to calculate g of x and then use the operation f capital of x. So this is kind of the easiest definition, the basic definition of the composite function. Usually we can face more complex situation when we have a set of functions here, a set of operations here. Generally we can have infinity number of operations, then we calculate this y value. So here you have a concept of the composite function. Okay. Assignment here. You have here 1 plus cosine x logarithm of the 1 plus x squared 1 over sine of x and the fourth one sine of logarithm of 1 plus x squared. There are 4 functions here. So here you can notice that firstly we have to calculate cosine x, then add 1 and then divide by here logarithm ln function. Yeah, I think you remember what is logarithm function. If you don't, write me down your questions and I will explain what about logarithm. 1 over sine x. Here you can notice that it is quite of easy example, but it has some pitfalls here. And sine of logarithm and logarithm ln function of 1 plus x squared. And the fifth one example here you have, for example, you have 1 over 1 plus 3x squared. Okay, this is your home assignment. Next, our lecture I dedicate to the derivatives calculation or differential calculus, and how to work with different examples using the rule of the derivative calculation of the compound or composite function. See you later. Keep your eyes on this course. I add gradually different materials as home assignments and some explanation. Read text I share it with you, and you will be succeeded in your work. So good luck, keep yourself healthy and your mind clean to absorb, to acquire new knowledge and new inspiration maybe.